welcome to that presentation. I'm going to tell you a little bit about what the future of industrial operations might look like, and if we all meet in the metaverse at some point in time, and probably when. So to start with, just imagine a day like that, and you're preparing yourself to go on a hike. And you're just saying, okay, that's like what operations used to be in the past. We know what to do, we prepare our stuff, we have our gears together, and we just go out, maybe go a little faster, a little further, but that's what we usually do, a little further each year. And then out of the sudden, the next moment you realize, okay, that's an interesting hike. You're basically hanging upside down. Yes, you have some gear, some equipment with you, but this is not what you really signed up for. But this is what operations is at the moment. It's not so smooth ride and just pacing along. It's really tough mix of challenges. And we have heard that the whole morning and all these challenges, discussing a lot in the panel discussion about talent, lack of talent. A new generation is coming into the corporations and is also stimulating a certain set of change. Or just think about the geopolitical situation that you had quite some intense grow up of tensions over the last couple of months and years. So globalization is now in a lot of mouths. Or just think about your business models. Will it still be that you just buy all that equipment which you buy today? Or would you just think, okay, what's about service? I get these things, software things running in the cloud. I want to also translate that into my hardware business and so on and so forth. Individualization, having more individualized products. Your customers demand that, and that ripples across the whole supply chain, the whole value network. So even if you say, okay, I just make out of basically crude oil some raw material products, and it's just base supply for the world market, it could also affect you at a certain point in time. It's a lot about resilience. In all that uncertainty which we have faced, in the old days where we just went on a hike, we were tuning, we were optimizing performance, we were cutting costs, and we getting OEE, maybe a couple of percentage each year. Now it's not only about cost, it's also about, are you able to deliver? And picking up on sustainability, and as sustainability is also the theme of that conference and that forum, I wanted to bring that also in perspective, why it actually matters. Why should we care? Why do we have to care, especially as industry? We are here at an industrial leading forum, and just to give you a couple of numbers, to say, okay, industry is accounting for 20% of the global carbon footprint. This is a significant number. This is 1/5 of the global CO2 emissions. There's a significant potential of savings out there. Or just think about 37% of energy is being consumed by industry. That is even significantly higher. So if we can be more energy efficient, we will definitely make a difference. And the last number is of particular interest, because what does it mean? Only 13% of the resources are being recycled. So just think about a circular economy going into the future, where the products of today are going to be the resources of tomorrow. This cycle is not closed at all. There's a significant potential to get that out. And if we go from climate, we have already heard about COVID and how that triggered virtual collaboration. We also in a more conflict situation, and we have an increased competitive situation out there. And if you put these starting letters all together, what do you end up with? C4. And you know what C4 is. It's quite explosive. But I always say I'm a positive thinker. I want to say, what's the positive things what you can make out of C4? You can really use that power which is unfolding also for the better, for the greater, and move mountains in a really in the direction you want to have them move. This is the trigger of transformation, of deep transformation which is going through industry. So no matter all of these challenges, one thing is certain. You have to deliver at the right time, at the right place, for the right price. This is what it all boils down to. And I want to say one thing about also Siemens here, that it's not only theory what we talk here. We are not providing you just with software. We have over 120 factories globally operating them ourselves. So we are in the same situation as all of you having own operations, because we have them too. We produce all our products there. We produce not only automation equipment, not only software, we even produce trains, we produce building equipment and things like that. So there's a significant manufacturing footprint which we also use as what we call customer zeros to apply our new technologies firsthand. So I spoke about C4 and how that basically the explosion could unfold potential for digital transformation, for transformation of industry. And we have heard that, just as in one of the questions in the discussion before, it's tremendously more the scale of speed, how that change is happening, is significantly different than all the changes happening in the past. And there are 4 ingredients I would like to share with you before we dive deeper into how that operations actually might look like and how we make it real. 4 ingredients what we think are really important to master them, to master the digital transformation. And the first one is the merging and the blending of the real and the virtual world. And we are talking about that for quite a while, and I will have some history on the digital twins going to the metaverse, but now it's a time that technology has evolved to a certain level that these blending of real and virtual world to make real benefits out of it starting to happen and starting to really can unfold the true potential. So this is the first level of integration. The second level of integration is just think about your process. Usually it's very sequential. You start with a design, then you do some simulation probably, you do some engineering, you do the commissioning, production, service, maybe some recycled. We have spoken about the potential of recycling. In future, these horizontal change needs to be more smoothly integrated, so that data is not, if at all, flowing from left to right, the data is smoothly integrated across the whole horizontal chain of these individual pieces. It's flowing back and forth. And we have that also seen in the digital twin picture from Axel in the panel discussion, that it's not only about bring it out once, it's also a continuous optimization of what's going to happen. And the third thing about an integration is a vertical integration. That's a vertical integration between the shop floor, the actuators and sensors, the controls, the compute nodes, and the cloud. So from OT to IT. And I have to say, will all go complete virtual? Probably not, because as long as we want to produce real stuff, we need to have some actuators, some sensors doing something. So a bit and a byte can tell a motor how to turn an axis and where to position it, and a sensor can measure it. But an actually physical actuator have to do that movement at the end. And I thought it's 4 things. The last thing is convergence of IT and OT. So we had that vertical integration already, that data is flowing not only horizontally, it's also flowing vertically. And we strongly believe, and we are an opponent on, really that converging IT and OT will do the trick and will be the basis to enable significantly the future of industrial operations use cases. And the shape of that slide is showing it looks a little bit like an X, because where does it come from? If you know that automation traditionally was, they think a lot in pyramids, this classical automation pyramid. And then you could talk to an IT guy and saying, oh, my pyramid is upside down because I have all these different kinds of IT systems. And yes, these shop floor things, that's just one knot. I consider that. And if you merge these normal and the upside down pyramid on top of each other, you're ending up with that kind of a figure. Now I would like to take you into the future. And how might that future of industrial operations actually might look like? So we have seen there's a tremendous set of change. We are all in it. We need some kind of levels or 4 levels of integration. So how can it look like? It could, for example, look like that. There's a company out there which is expecting in 10 years from now that they still need to produce cars. But if you just look at that manufacturing of the future of their industrial operations, how they have expressed it in a conversation with us, it looks very different than today. It looks very different than the assembly lines envisioned by Henry Ford. It's more open shop floor, open spaces, things flexibly can maneuver around. It's a lot of data being integrated. It's a high variety of models, because what they said is, yes, I will produce cars in the future, but I have a very much closer proximity to the market where I want to sell. So I built a factory for that particular market, and I want to produce any models I sell in that market in that factory, which is a significant difference than today. Flexibility on a very much different level. And you also see quite a few people in there, in the shop floor. And this was also quite astonishing to me, that they said, we actually expect that there might be even more people in the shop floor than today to cope with that flexibility. And we have all heard, and I can just tell you, other dreams of the customers I've spoke with, you could just close your eyes, and then you see it. Then you see into the manufacturing of the future, it's a dark factory, it's a lights-off factory, nobody around there who needs light, so meaning new humans. That's the complete opposite. Both will be there. Or a different picture from another company in a different area, more in the pharmaceutical area. Their dream is to know you all, each of you, better than you actually know yourself. And they have a digital twin of each of us and will be able to use it to produce exactly the medicine you need, in the case you need it. And this is also lot size 1 production at its best, because it might even take in a sample of your blood or whatever of your cells to produce your personal recipe, your personal medicine, which you might need in that case. And things like cybersecurity, traceability of that products, trust is important. And just imagine, if you want to go to a factory today, you have to physically move, you have to go there. That customer dream is actually also that a factory comes to you. You could be the hospital in future that you say, I have a factory in a box. So I ship my factory to the site where I actually need to produce that stuff. Where's yours? So that's an invitation, and you will see that QR code for 2 more times within the presentation. But here it's really your opportunity to get your future of industrial operations picture. I just showed you 2. And these 2 are very unique, and they are customer specific. We have almost 90 pictures meanwhile. So over 80 customer conversations we have done in the last 18 months, which is usually a 2-hour conversation, very open, not much preparation needed, and it's really an eye-level conversation on how might that future of industrial operation look like, in particular for you. Across all the industries, across all verticals, discovering a lot of use cases. And these use cases, we use them to derive not only the portfolio we need today, but actually the portfolio we need to serve your dreams, to enable and make your dreams become true. Because the picture just is emotionally expressing what is your dream about and your future look like. What did we take from that? So you could say, okay, talking with 80 customers, what have you learned? And I will give you some insights into that data set on these future discussions, their dreams. And we were able to boil it down on 8 leading dimensions. So on these dimensions, I could classify a future scenario quite well and distinguish it from each other. It's, for example, the localization aspect. Will it be a very global hub? So will I have a world-scale factory somewhere and serve the world? Or will I have really localized production like a factory in a box? Will I have a single factory? Will I more have a network? Will I have the mass production, also quite linked with lights-off factory? Or will I have a fully customized production? And will I have also high percentage of manual labor in there? What's about your business model of the future? The business model actually varies way more than today. And there's way more thinking into, okay, service-oriented business models compared to the CapEx-oriented business models we are in today. So we know that 24/7, the continuous operations, especially in process industries, the batch operations, the discrete assembly, all that will still be there. There will also be manufacturing or production lines in terms of shop floor designs, but also all the way to very modular cells. And it will be from more closed systems and centralized systems to also more open systems and very decentralized systems. And guess what? If we now have on each of that scale, just pick 1 to 5 and classify them where they are, with the customers we have spoken to, we could identify each of that scenario. So almost 65,000 different variations of future operations scenario. That's quite a number. Over 65,000, so that's a variety. So do we now go to lot size 1 also in operations scenario, or can we also find some common denominators to make that dreams become true? And therefore, I would like to share with you some kind of, just imagine if we would have these upcoming 10 innovation fields solved. Starting with flexible production, and I covered that with the automotive examples, that it's really a high mix of products producible in that factory. It's getting more interdisciplinary. So not only in engineering, also in operations at the end. Different kinds of people with different kind of skill sets needs to come together to leverage the full potential. Transparency, wherever you are, whenever you need it, whatever you need it, should be there. Seamless human-machine collaboration. I in particular like that we speak a lot about human-machine interfaces. Tomorrow it's about human-machine collaboration. So how do I use that machine intelligence to enrich my workflows? And going into prediction and continuous optimization. So there's no such things as standing still, tuning the manufacturing operations, putting it on a spot, and then just produce for the next 10 years. It will be continuously optimized further and further. Sustainability management, for sure, cannot miss. So you need to look into that. It starts with energy efficiency and ends with circular economy. It's about the value chain transformation. This is about the business model. So it's not only about technology. It's also a lot about business model. It's also a lot about people. It's about self-adapting machines. So how do I actually adapt, have machines which are adaptable and having an increased resilience level? And it's also not only about building new factories. There's so much installed base out there which we need to leverage. These brownfields installations, usually they have no connectivity to anything, which is also good from a cybersecurity perspective, but quite bad in terms of leveraging higher value use cases predictability. And I already mentioned the IT and OT integration, which will be significant and also a significant game changer for us as providing new technology. And more in particular, imagine you would have 4 things. First, you have flexibility through is separation between software and hardware. And that means looking at control, separating your control function, which is usually at the moment coming in a box, hardware and software glued together, separating that because you still will need control in 10 years, but where you run control will become much more flexible. You could deploy it in the cloud, you could deploy it on a data center, you could deploy it on an edge, you could deploy it on dedicated hardware. And now just think about what we all use, our smartphones and so on, our IT equipment. When was the last time you have seen your IT staff, your IT management, which coming by and installing an update on your device? You say, do we have an IT guy? So yes, you never see these. They just dial in remotely, but they know if you're late on a security patch. And they would say, okay, if you don't do it, you will not be able to dial into the company network in whatever time. So better get it done. In OT, if I look at the OT devices and there's something, okay, this and that device needs to have a patch, what is then going on? I need to buy a pair of running shoes for that guys running around the factory to figure out, do I actually have that device? If I have it, how many, where is it, and so on. And then I always say, okay, then you get them also a heavy laptop that they not only run, that they also have something to train their upper body muscles. And then, then you basically get out there and run to each of that devices and update it. Why not doing it in OT the same way as in IT? To manage your OT devices centrally, updating them over the air without the downsides of IT, meaning cybersecurity. So having a secure OT from respect of cybersecurity. And then easy ways to build the digital twins. To build it, to deploy it, and to maintain it. Because I have seen so many digital twins in my life already, which have been built up once and then have been used for a while. And then maybe somebody left the company with experience on a digital twin and then it just retired. What a pity. Digital twins, bringing us a little closer already to the metaverse. So what's a digital twin? A digital twin is really a comprehensive representation of a real-world asset. So it's really simulating, predicting, optimizing the product. And where does it come from? So we start here from having some basic models on geometry, single physics, 1980s, then getting into the CAX, what is here, Sunrise, the CAX age, where I say, okay, they just put the construction board where you just draw with your pencil, they just transferred that behind a screen. Then we have PLM, more model-based engineering, collaborative approach, exchanging data, and so on. And we are now in the digital twins, that everybody has digital twins. You all understand different things from that, but it's basically there. You probably all use some kind of a digital twin. So just saying, it's not just future, it's also there today. And this significantly helps you to classify your digital twin on which area you are using it, on an equipment level, on a process level, on a plant level, in which phase of the life cycle. And what is actually the use case? Do you use it for creating that digital twin? Do you use it to keep it evergreen? Or do you actually use it in the operations phase? And this distinguishes the digital twin you need for that specific purpose. I always say models are purpose-oriented. Not only the business is purpose-oriented, but usually also the digital twins. And you can create and maintain the digital twin already today, starting with tools like, for example, Comos for the engineering of a plant. You can simulate that significantly by physical simulation models, for example, with GPROMs. Yes, you automate that. That's what we all know. We have these automation equipments, the SCADA systems, the DCS systems, and so on and so forth. We have more simulation for virtual commissioning, taking the virtual plant up. And then we also have the operations and the maintenance phase, which is probably the longest. And there we need optimization. We need to have also some enablement of mobile workers to equip them maybe with some kind of digital assistance that they know where to go, and to hook that up to realize the next level of out of your data, out of your plant. That's all available today. And to prove that, you have that tools, you have that technology, this is available, it's installed in plants and used by customers like BASF, where they actually integrated these tools and realized that tool chains on their own to use it for modeling, data management, simulation, and then also operations and optimization. And another optimization example I in particular always like to share is that because if you optimize and use model-based technology, digital twins, wisely already today, you have a significant saving potential. So just 2.8 tons per hour more yield out of a refinery. Well, I think that will make quite a significant number at the end of the year. From digital twins to the metaverse, to coming closer to the question if we will all meet in the metaverse at some point. So what is actually the driver why metaverse might be happening at the moment? There was a significant scale up in computing power, in connectivity, new technology, 5G and so on, enabling you to transmit data at a very different latency and pace. The equipment, AR, VR, it's dropped so significantly also in prices. If you just imagine you wanted to buy an AR glass with specific PC, I think 5 years ago, $5,000 or something like that. Now you can buy that for, I think, 400 or something. You can get your goggles. And then we learned to collaborate way more in the virtual world. We also learned that it's necessary and it's quite beneficial not to travel every time and sleep in planes. So acceleration in terms of immersion, in terms of interaction, collaboration, and a digital exchange. That is factors which could bring the digital twin to the next level. So the digital twin to the next level is that what we call the industrial metaverse. So embed these physics-based, that real-time capable, photorealistic digital twins into something which we would then call an industrial metaverse. And here we are. It's democratization, it's real-time plus predictability, which will really make the next level from a digital twin as we know it today to a digital twin deployed and used in the industrial metaverse. So let's make a little bit more specific. How could we envision the industrial metaverse, and what is it good for? What would I use it for? So an industrial metaverse still requires that you have some real asset. So you have a real asset, a real production, in manufacturing, whatsoever. But you could, for example, think about design and engineering. If I'm designing a new product, can I also enable my customer already to experience that product in a virtual surrounding beforehand? Can I explore if that customer likes what I'm trying to build, what I envision to build, could make it even more suitable for his or her particular needs? Yeah, we have also spoken about applying that in a plant context, that you don't basically smell if a pump or whatever is burning, and you maybe not have that feeling of, oh, it's quite risky because I'm sitting in the control room and below me is all that equipment, and if that's starting to burn, so I better get that job right. If I'm just 1,000 kilometers away in my virtual world, I think, okay, maybe that's like a computer game, but there's something serious happening. Virtual testing, validation, to really prove that that product and that production is working properly before I move that. And this is really an immersion between the real and the virtual world, because here I experience that virtual product as they would just stand in front of me. For sure, the production has a digital twin, at its best. You could even walk into that production. You will see that in a second. Imagine that guy. Will it be all like Ready Player One? We have our suits and our goggles on, and we standing in shabby whatever containers, and then just go somewhere? Probably not always, but it could be, especially with that thinking about lack of talent, accessibility maybe of that maintenance guy who knows that equipment best. But maybe that maintenance guy could send somebody out there, a robot or another person, and could direct it and could do that fixing remotely. Would be cool, because also not all the plants are at very attractive areas. And for sure training. Training could be lifted up to a completely different experience. And also that, back to lack of talent. So just look into the crowd of that audience here and at the forum in total, how much experience over the next years we're going to retirement. How do we replace it? How do you get 20-year-old people with 30 years of experience that they could actually do and operate that plants safely and reliably and optimal in future? So training really at a different level. That is, I think, also probably one of the first use cases besides that one, which I think will be a breakthrough for the industrial metaverse. And now 2 examples of what's also available if we look at the metaverse. This is really how realistic it could already become today. And the capability is that real-time thing, that you just change the circumstances or just say, I want to recolor that, and it's just recoloring. It's redecorating my stuff, and this at real time. This is all real time, and this is doable with that technology, combining NX rendering technology with NVIDIA technology. And now I take you into a production site. And you need to look at that probably twice because it's so realistic. And this is the virtual production. But it looks terrifically realistic compared to the real production. You will see that all the details which you would see in the real production side. You could say that's quite cool, and this is also quite nice technology. Would be a cool computer game to have these kind of graphics and to run there through in real time without any hiccups. So how do we make that real? How do we take that all, combine that all to answer to the challenges which we all have? So the C4s and so on, to answer that, to integrate the virtual and real world, to integrate horizontally the data points, to integrate vertically across the chain, and to merge OT and IT together, and to make the dreams become true. How do we make it real? The basis for us as Siemens is to provide you all, us all, with a promise, with a pledge to form an open digital business platform which we call Siemens Accelerator. And this is pretty new. That's, I think, born 6-7 months ago where we launched that. And this is designed to overcome that hurdles of the digital transformation to a completely new level. And this Siemens Accelerator, it's consisting out of 3 important elements. So as mentioned, it's an open digital business platform. Open is very important. And it has 3 pieces. It has a portfolio piece, a portfolio which fits well together. But this portfolio doesn't only have to come from Siemens. It can come from anybody playing within that ecosystem. And if everybody could bring I would say, some food to the table, I would like to have some transparency. And therefore, you need some kind of a marketplace mechanism. I said it's a promise. It's not a product, a platform which you just go and buy. It's something we create. It's a promise to ourselves, a promise to our customers that we go that way, that we will transform ourselves significantly over the next couple of years together with you into an open, flexible, interoperable as a service portfolio, which will collaboratively being created in an ecosystem, and where these modular offerings can be transacted through a transparency mechanism, which I call marketplace. And no matter where you stand today, if you have a traditional plant not connected at all, if you have a little bit digitalization, or if you have already a smart plant, you can start anywhere in that picture, anywhere in that journey. Each journey starts with a small step, and then step after the other. Or in different words, I like to play a lot with Lego when I was a younger boy. I still like to do it playing with my kids with Lego. Lego is, for me, an example for a modular portfolio. This is a modular portfolio. You could say Duplo, Fischer Technique, and so on. They are also modular portfolios. Be better, agree on that we want to play Lego together. So this is something, modular architecture, which we need, which is portfolio. Then you need accessibility to that technology, because otherwise it's worth nothing, a marketplace. And playing together is more fun, isn't it, than playing just with yourself? So partnering and collaboration, it's growing through collaboration. These challenges we have discussed at the beginning, things like climate change, nobody of us, no company alone will be able to master that. It has to be solved by a next level of collaboration in open digital business platforms, in ecosystems, going away from ecosystems to ecosystems. That's the fundamental mindset, growing through collaboration. And this is also where we can start. Do we all meet in the metaverse? I would say we can meet face-to-face or virtually as human beings first, and to catch your dreams, because if you can dream it, we can make it real. If you can dream it, you can do it. You can figure out who said that, because this is also something which fits well to Orlando. But this is a statement, dream it, make it, which we have signed up for also Siemens Digital Industries. And it starts with creating that visionary picture and then going into co-innovation. So we not just say, okay, we create a nice picture and then we are done. We want to follow through all the way until this thing is implemented in your operations and your dream become true. And this will be a journey. It will be a joint journey, but as said, each journey starts with the first step, and this is what I'd like to invite you with for. Let's transform industry together now. Connect, join us in that innovation journey. Connect with me. I will be around for the next 1.5 days, so we can have a chat anytime you like, and also virtually, so we can also meet in the metaverse, which at the moment Teams. But as said, I'm a strong believer that also in future, metaverse, up or down, business will still be made between people, because we have heard about hearts, and this is what differentiates us from machines. And this will be a significant game changer, bringing all our capacity together to make the dreams come true. Thank you very much.